Welcome back, everybody. This is going to be episode 9 of our Intro to KSP series. Today we're going to introduce a more advanced construction concept, and then we're going to get into orbit and start adjusting our orbit once we're up there. This is where we start launching into the more expansive part of the game, where you explore the solar system and undertake bigger missions. But in order to get there, we need to understand how to navigate and how to control our ships in orbit. So to start with, we're going to come to the R&D facility, where we're going to spend our 40 science, and the only thing we're going to get is the stability option, and that's because it has a radial decoupler. So this TT38K radial decoupler is what's going to enable us to take the next step in terms of our construction abilities and the kinds of rockets we're going to be able to create. So we're going to get this, we're going to research that, we've got it. We don't have enough for advanced rocketry, but that's okay. We'll just carry on with this stability upgrade. So we come to the VAB, and you can see I already started building something earlier, so we'll get rid of that. Up until now, our rockets have only been in one stack. We've had one kind of core, and we've just added stages to the bottom of it. But eventually that doesn't work, because the rocket gets too tall, it's going to get unstable. So what we're going to try doing is adding stages to the side. So here's our upper stage. We'll make it nice and powerful. Lots of delta V up there. That should be plenty. We'll add a decoupler, and again, just building out our rocket. We've pretty well seen this before. We'll add one more fuel can there. We'll add a swivel on the bottom. Make sure that's a swivel up there. Yeah. Okay. So we'll clean up the staging a little bit here as well. So if we click on this, we can see some more data. First of all, thrust to weight ratio, TWR. So that's 1.44. That means for every pound of rocket we have right now, we've got 1.44 pounds of thrust, which means we should be able to get moving. If it's above 1, the rocket will gain momentum. If it's below 1, it's not going to be able to gain momentum, because you don't have as much thrust as you do weight. So what we're going to try to do is add a little more delta V to this stage, because we want to be able to go fast, change the velocity of this rocket more. But we don't want to just add stages to the bottom. Like I said, it gets very unstable eventually when you get too tall. So we're going to come over here, we're going to use our radial decoupler, and it goes on the side. So we've done this with science parts already, but we're going to try this with this decoupler, which will allow us to add fuel tanks to the side of our rocket. So just going to place it correctly there, make sure it's straight, it's not off on a little angle there, and then we'll just add more fuel tanks, and then we'll add some engines at the bottom, and then we'll grab this whole piece, because once all these pieces attach to this piece, in order to move this, I just have to grab that base piece. And now it becomes ghosted, and I can put it and align it so that it's all even across the bottom here. That looks close enough. Okay, so one of the other things that came with stability is an aerodynamic nose cone. So we'll use this. Looks cool. There we go. So what have we done? We're going to close that, make sure all 3 of these engines are in the same bottom stage. And it looks like we've added some delta V. We went from about 1300 to almost 1700. But our thrust to weight ratio is 2.14. So that's going to accelerate pretty fast. So what we can do in this case is if we want to reduce the amount of thrust, rather than taking an engine away, we can just reduce how much thrust this particular center engine is going to produce. Let's say bring it down to half thrust. Notice that the thrust to weight ratio changes. So that means it's not going to accelerate as fast because we have less thrust, but this engine is going to burn fuel from these tanks, the center tanks. And because it's operating at 50% the power these side tanks will burn out and they'll be empty. And that's when we can detach them using the radial decoupler. And then we'll still have our center stage. And when we do that, we're going to have another almost 900 meters per second. So all told, we've added well over 1,000 meters per second. Well, probably about a little bit more than 1,000 meters per second to this rocket. And then after all that, we'll have our upper stage that is still totally usable. So this should be able to get to orbit, and we'll give that a shot right now. I'm going to speed it up because you've seen me fly to orbit already. Okay, there we are. We're in orbit, or are we? So this time we got our apoapsis up to 167,000 meters. So that's quite high. But our periapsis is still down at 68,000 meters. So as we know from before, the Kerbin's atmosphere goes up to 70,000 meters. So that means that this spacecraft is not quite in a stable orbit for the game, because 68,000 meters is just below the edge of the atmosphere, and the capsule will encounter atmospheric drag anytime it comes through the atmosphere. Over time, that will drag the whole orbit back in, and eventually this capsule will re-enter Kerbin's atmosphere. So that's not exactly what we want. We want both the apoapsis and the periapsis to be above 70,000 meters. So the easiest way to fix this is, because we have lots of delta V left, is we're going to let the craft orbit all the way around to the apoapsis, and we're going to perform what's called a circularization burn. So that's going to bring our orbit from this slight ellipse that you see. It's a little bit wider at the apoapsis side and a little bit thinner on the periapsis side. We're going to bring our periapsis up to approximately 167,290 meters. So that's called a circularization burn, and that will ensure that the whole orbit is outside Kerbin's atmosphere. Alright, so in order to do that, we'll use time warp, which means we'll click right about there, and we'll warp here. And the game zooms us forward so we don't have to wait 40 minutes to get out here. And we can enjoy the views of the solar system for now. Alright, very close. So we're 30 seconds away. What do we need to do? We need to go to prograde. You can see our little ship here going around the Kerbin. And we're just going to use just a little bit of throttle. Just not very much at all, just like one tap of shift to see if we can get this side to start, the periapsis to raise a little bit. You can see very quickly, almost no thrust at all, and we're a few meters short and just another tap of the throttle, and we're above the atmosphere. So now we're above 70,000 meters on the periapsis, and we're out of the atmosphere. So this is now a stable orbit. It won't encounter atmospheric drag, and it will stay. So if we want to get it perfectly circular, we can get really finicky, and we can bring the thrust up maybe a little bit more, because we have to get to 160 something. But now you can see the apoapsis is moving away from us behind us. It's going up now too. So we have to keep track of both of them. Let's see if we can do it. I don't know if we will, because the apoapsis is already higher than we are now, and the periapsis is coming up. So that's okay. It's mostly circular. We've got 171 kilometers, almost 172 kilometers by 161 kilometers. So that's using prograde to raise your orbit. Now, if we want to adjust the orbit a little bit without raising any side, we can use some of the other modes. Instead of just prograde, we have retrograde, which will lower the orbit. We also have radial out and radial in. So let's see what radial in does. I'm just going to click it, and we'll see that now the ship points straight to the Earth, or to Kerbin. Look at that, it's pointing straight down. That's our planet, that's our ship. If we were to burn the engine now, what would happen to our orbit? Well, let's find out. So same, just a little bit of thrust. We'll see what happens to our periapsis. Uh-oh, looks like it's going down. That's not what we want, because now our periapsis is going down and our apoapsis is still raising. So what we're doing when we do this is we're trading the energy from one side to the other. So we're taking altitude away from the periapsis, potential energy away from the periapsis, and putting it to the other side of the orbit. So if we do the opposite, radial out, where we're pointing away from the planet, and burn the engine, let's see what happens then. Look at that, our periapsis comes up and our apoapsis starts to go down. Let's see. Alright, so now our periapsis is about 164, 165, apoapsis is 168, getting pretty circular. And we'll try to get it really perfect. If we want to get it really perfect, what we can do is go radial in. That'll bring our periapsis back in front of us. Then we can quickly go retrograde. Wait till we're right at it, 15 seconds away. Close enough. Let's just tap that throttle again. And look at that. So 164,923, 164,824. So 100 meters. We got that orbit pretty darn circular, just by using prograde to raise the orbit on the opposite side, retrograde to lower the orbit on the opposite side, and then radial in and radial out to stretch the orbit across the whole orbit. So essentially what you do, whatever you do on one side of the orbit affects the other side of the orbit. So have fun playing around with radial in and radial out, as well as minor deviations in prograde and retrograde to achieve that circular orbit. That's all for now. Next time we'll talk about how to get encounters with celestial bodies such as the Mun.